the coordinate plane. The coordinate plane. And it's called the coordinate plane, coordinate. What goes here? Plane. And basically, if we didn't have GPS anymore, you'd have to know how to use this a little bit more, because that's how maps always were. But you can think about this: if you were a plane out in the ocean, and you ran into trouble, you're halfway between here and where? England or whatever. You ran into trouble. Charlie, how are you going to tell somebody where you're at? You can't just say, I'm by that big wave over there, because there's millions of big waves over there. You can't just say, I'm underneath that cloud, because there's all sorts of clouds. You would have to give them your coordinates, because we've taken, the Earth is split into coordinate plane. We call those lines of latitude and longitude. We've cut it into a bunch of squares, and you can give somebody those coordinates, and they'll know kind of where you're at, because your plane tells you where that is. And that is the first thing we talk about with coordinate plane is we do what's called ordered pairs. And they're called ordered pairs because the order of them, well, they come in pairs, and the order matters. Okay, the order matters, and they're always separated by parentheses. The first number in the ordered pair, let's say, let's do the one they have here, 3, 2. In an ordered pair, the first number is called the x number. It is also, if you want to think about it, it is the over number. You go over that many places. The second number we call the y number, and it's the up/down number. So if your ordered pair is 3, 2, there's a couple different ways to think about it. You can go, first of all, we start at what we call the origin. By the way, the origin is point 0, 0. It's where the two axes come together, and the two axes, I guess we should go over. This is the x-axis. It is the horizontal one. The vertical one is the y-axis. And if your ordered pair is 3, 2, if you start at the origin, you go over 3 and up 2. That gets you to that point. You could also think about it like this. Looks like pizza's on its way. You know, you think about this is the x number. X is 3. So you think about that little line that is where x is 3. And here's where y is 2. There's that line there. The place where those two lines cross is the point 3, 2. 3 over 2 up. If it's a negative number like the second point here, negative 3, 2 means instead of going to the positive side, you have to go to the negative side. 1, 2, 3, and up 2. And that's your point right there. And then negative 3, negative 2, positive 3, negative 2. And that's the whole ordered pair gizmo gadget there. We have this coordinate plane. It is cut into quarters. Here, let's do a little coloring. We've got this quarter here. That quadrant, guess what? That quadrant is called quadrant number 1. And for some reason, people decide we always use Roman numerals for quadrant number 1. This quadrant here is, guess what? That's kind of ugly. This is quadrant number 2. That's Roman numeral number 2. This one right here is quadrant number 3. And the last one there, I don't know what color I have left. This one here. Anybody know how to make a 4 in Roman numerals?
Oh, what do you do?
Yeah. It's not 4 slash marks, it's IV, quadrant number 4. Quadrant number 4. Now let's do Let me make sure I have this one. Order pair, echelon axis coordinates. So, let me do a fresh page here. Oh, look, there it is. Let's say I have this dot here, and I asked you for the coordinates of that dot. I would do, the first thing I would do is put a parenthesis and a comma. And don't get confused which is which, although this one it doesn't matter. Okay? The first number is the x number. So you find, if you drew a line straight down, where does that cross the x-axis? At 4. Second number is the y-axis. This is the y thing here. And you go across on the y-axis, and it's 4, 4. How about this point right here? What is the coordinates of that point right there? Coordinates of that point right there. Samuel? Negative 4 what? 1. Wow. Nobody's upset with pizza, man. Negative 4, 1. Charles, your question? How about this point right here? No, I don't want to put it there. Sorry, let me change it. Let's move it to here. What would that point right there be? Ephraim?
4, 5.
It is not 4, 5. 4, 5 is right here.
Oh, negative 4.
Negative 4, negative 5. And it's kind of important to note, all of the numbers, if you have an ordered pair in quadrant number 1, both the numbers will be positive. If you have an ordered pair in quadrant number 3, both numbers have to be negative. If you have it in 2, x is going to be negative, but y is going to be positive. And if you have it in quadrant number 4, x is going to be positive, but y is going to be negative. How about that for some interesting stuff there? CJ?
Does it have to be, does it have to go, y-axis and x, or can it go y and x?
I'm not sure what your question is, but the x has to come first.
Yeah, that's okay.
Always. Always. Now, where people get confused, ladies and gentlemen, is when numbers fall right on the axes themselves. For example, if I put this dot right here and I ask you for that ordered pair, what is that ordered pair? Okay. Again, you think about where it crosses the x-axis. It crosses the x-axis at 0, and it crosses the y-axis at negative 3. Or, what is that coordinate, Charlie?
0.
It's not 0, 3. It crosses the x-axis, which goes first at 3, and it's 3, 0. This point right here, Trevor?
Negative 4, 0.
Negative 4, 0. And how about this point right here? Samuel? Negative 6. 0, negative 6. Let's see what they asked you for here. Is there something on the back of your piece of paper? No. I'm going to give you one more piece of paper. That has 2 sides to it. One of them, we'll talk about the other one. Don't mess up both sides. You will. And then open your books to page 365. 365. 365. 365. We'll get there eventually. And look at problem number, let's just go with number 7. Problem 7 on 365 says, the vertices, the points of a rectangle are located at -2, -1, 2, -1, 2, 3, and -2, 3. Graph that rectangle. Go ahead right now, you plot those 4 points, see if you get them right, and then I'll do it, and we'll see if we're on the same proverbial page here. You plot those points where you think they go, -2, -1, 2, -1, 2, 3, and -2, 3. You plot those points, I'm going to plot mine. It would be very nice if when you do these sort of things, you actually use a ruler, some sort of straight edge, so your lines are nice and straight, but that's usually a lot to ask from 6th graders for some reason. See if your points match up to my points. Now take a look up here, make sure your points match up with what I have here. 2, 3, 2, 3, and -2, 3. And hopefully your lines match up with my lines. And oh boy, my straight lines don't end up. It's about as good as mine. That's about as close as I think mine's going to get. Does your rectangle look like my rectangle? If not, try to figure out why. Your rectangle should look like this. Now here is what I must caution you on. I have 7th graders that struggle with this, maybe even 8th graders. The book goes on to ask you for question letter B and letter C. What is the perimeter and what is the area? Now take a look-see here. What is the perimeter and what is the area? You have to be very careful when you're looking at counting. This thing is not in inches or centimeters or whatever, it's in units. Each block is a unit. Now when you're counting the dimensions of these squares, please understand this. Do not count the tick marks, the hash marks, the lines. Because if you do that, you're going to get a wrong answer probably. So you can't go, this is 1, 2, 3, 4, 5, and say that this is a 5 whatever units long. It is not. You must count the spaces between those lines. In other words, this is 1 unit long, 2 unit long, 3 unit long, 4 unit long. This is 4 units this way. Same thing going up. Don't count 1, 2, 3, 4, 5 because you'll get messed up. It is 1 unit is that long, 2 units, 3 units, 4 units. So the perimeter would be 4 plus 4 plus 4 plus 4. It's actually a square. 4 times 4. Perimeter is 16 units. Wait, 12 units. I'm not sure what. Wait, 16 units. Why am I thinking? Probably because the area is going to be the same thing. Area is also 4 times 4. is, which is 16 units squared. And if you counted how many squares it takes to make up the shape, you would get 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Hip, hip, hooray. And also, on a side note, ladies and gentlemen, focus with me, listen to me on this. Well, I will even pull it up. I got it right here. When you are given problems, I'm actually going to get a very good piece here. Wait, say that again with me. When you are given problems,
When you are given
problems. Let's say here's box number 17. Don't say that. Here is 17. It's a little big, but that's neither more nor less. If they tell you to graph or plot points 3, 4 and -1, 2. You will notice that on your homework, although yours is gray, mine is green, you already have a grid system set up. You will use the grid system that is already there. In other words, I don't want to see this. You just go and randomly make marks on your paper. You already have one that is going to be very nice to do because you already have the lines there. You will use a line that's already there, use a line that's already there, and then this can be 1, 2, 3. They are already there. Use those. Don't go making some willy-nilly hash marks wherever. And then when you plot the point, 3, 4, 1, 2, 3, 1, 2, 3, 4. I don't care if it like ends up somewhere in the boondocks or wherever there. -1, 2, -1, 2. Got that? You will use lines provided. It's just a good idea. It will save you much misery later on. Samuel, is there a question on that? Just be smart. You know, you're not going to do this and go, oh, look, I'm just going to make my marks whatever I want. And there's no point. Because you can't tell, I can't tell what's going on here. Now,